Make it any smaller.
I'm using Evernote, and the formatting's a bit off. So anyway, right. So I've noticed that a lot of people have actually, joined this group and are interested in Python. However, don't know much about how to actually go out and learn Python or what it's used for. So this is for that. Right. So actually, before I go ahead, I'm just going to tell you a bit about me. So I am a network security engineer. So I use Python every day for maintaining servers, getting data across, etc. There's a lot of things. Python's a very versatile language. So I use it in my job, in network security. So
He's a hacker.
Right. So Python is a dynamic programming language. So it's similar to Ruby, Perl, Java, in regards to it's an interpreted language. So that's how it's similar to Java. Syntax, you could say, it's not exactly like Ruby, but it hasn't got much syntax overhead, so you could relate it in that way. So so it's clear, readable, and it's got dynamic data types, and used in many things, such as building websites. So I'm sure you guys have heard of Django, or Flask, maybe. Anyway, Pinterest, I'm guessing you guys have heard of, or Firefox, or Instagram. I'm sure you guys have heard of Instagram. They use Python for their websites, using the Django framework specifically. So a lot of people that have come here as well, I've noticed that they do data science, data analysis. Python also has modules. So modules are, you can look at them as tools for Python for data analysis, such as pandas or matplotlib. So you have a lot of data in your databases, and you want to analyze that data, manipulate that data. We have an ample amount of resources to actually do that with the data. So instead of you writing your own code to do that to the data, you could just use the already made code by other developers, and that's what pandas and matplotlib is. So like I said, with maintaining servers, Python, you can write scripts in Python to, for example, let's just say I have a server which I want to update files on from a Dropbox account. I can make a Python script which will synchronize the data from there to the directory in the server and have that run every day. So you can use Python for that. Teaching programming, like I am now, so because Python just naturally doesn't have much syntactical overhead, so you haven't got the curly braces, semicolons, and so on and so forth. It's much like executable pseudocode. So you just write the code as it is, and it executes. You don't have to fiddle around with, braces, semicolons, this and that. So it's really good for teaching programming. Actually, MIT switched most of its programming intro courses to Python because of that. Games. So those of you who are interested in developing games, there's a library called Pygame, which is massive for Python, which you can actually develop games in, and many more, which we'll go over. Cool. So there are some exercises that we will go through. Now, you can either, if you have Python installed on your laptops, now most Mac machines will have Python installed on them. So if you go to your terminals, if you guys can do this now, just so everyone's actually, we can fix errors. So if you have a Mac, you can just type Python in the terminal, and it should be 2.7, which is the version of Python we're using. And if not, we can go on a website. So it's an online Python IDE called REPL. So let me get that up for you.
Can we do just slack rip it out?
Yeah.
Alright, yeah, if you could do that. So I actually wrote this whilst I was on the train. That's the REPL link. So it might not work. It might. I'm not sure. Can someone try it? I think it is right.
Seems to work.
Yeah. Cool. All right. So this is what we. Well, because I only have half an hour, we probably won't go through all these. However, if I will carry on because we're going to have a Python hacker room after. So if you are interested and want to carry on, then we can carry on there. Right, so we're going to go over data types and operators, variables and collections, control flow, functions, classes, some goodies that I have for you, and I'll also provide some additional resources for you to actually go out and learn Python yourself. So these are actually resources that I found helpful. Right, so let's begin. So comments in Python. So how to, so you could look at comments as a programmer's note within an actual Python script or within the actual programming or code, whatever. So a one-line comment, you can write it by actually adding a hash in front. So you add a hash, and what that would do is that would just tell the interpreter not to execute this code because it's a comment. So that's a one-line comment, is a hash. If your comments are going to get longer, you can use a triple quote over multiple lines, which will create a multi-line comment. So if you want, you can actually follow along with your with the Python open or the REPL, so you can actually just experiment with what I'm showing you. Right, so numbers and math in Python. So it works just like your traditional math, really. So you have numbers and then you have operators. So for example, on your IDE now or on the Python interpreter you have open, you can try to execute 3 plus 5, and the answer that will come back to you would be A. So that's how math works. So you can use the plus, minus, times, and division. However, something in Python 2.7, which is what I'm using now. So let me make this clear. We have Python 2.7, which I use, and then we have the newer version of Python, which is 3.5, which not many people use right now just because it's quite new and everything written in 2.7 just isn't compatible with 3.5. So one difference is the division. So in 2.7, if we were to provide number 11, divide it by 4, it will give us 2. Now, that's because we aren't providing a float data type, so we're telling it we want to divide integers and not floats. However, in Python 3.5, it will automatically just do float division. So for 2.7, we're going to actually have to provide a decimal point and 0 for just to tell Python we want the float division. So that's one difference between 3.5 and 2. So as you can see here, we're actually providing that float data type by decimal point and the 0 and that just tells it we want to divide with float numbers. Right, so to order your operations, so let's say we want to add 3.5, sorry, to add 3 and 5 before we divide it by 4, we just wrap it around in parentheses, and that way we execute that first, and then divide it by 4. And then have that all times by 3. Right, booleans. So to store whether something is true or false. So in most languages that I've come across, booleans would be true and false. However, lowercase. So you'd have the false and the true in lowercase. Now these are data types. Now in Python, they have to be capital. So the true and false data types must be capitalized. Right, and to negate these booleans, you would have to add the not keyword in front of it. So for example, if you want to look for something that's not true, you would use the not keyword and the true keyword, like that. Right, so there's one more data type, and this is to check whether an object is empty, and that is none. So have you guys come across null? I'm sure JavaScript has null. So none is just like null, that's all. So if we have an object that we want to check whether it's empty before we actually operate on it, then we would check if it's null first. Sorry, none in Python. Comparisons are just like other languages really. So you have the greater than, less than, greater or equals to, the equality and the inequality. Now one thing about Python is chaining. So you can actually chain these comparisons. So for example, the last one here, we have 1 less than 5 and 5 less than 10. Now we can chain as many of these as we want, and we know that 1 is less than 5 and 5 is less than 10. So that will give us true.
Sorry. So what happens if you do 1 is greater than 5, less than 10?
Well, it would be, so the one in the middle would be compared to the outers. So it would be, so what was yours again?
Sorry, if 1 was greater than 5, so that's false. Less
Right.
than 10, that's true. So would you evaluate
That would be false.
false is less than 10, or would it evaluate?
It would be a false. It would be a true, false, false. So it would be false.
Okay, so they're all of them have to be true for
Yes,
this to change.
yeah.
Right, got it.
Right, so is, the is keyword. So is using, sorry, so is comparing the type of an object. So for example, let's just say you have a list. You have a list of different data types, data type string, data type integer. You want to operate only on the string data type to manipulate the string. So when iterating through this list, you would check whether the data type is a string by using the is keyword. So we would go through the list. If the next element in the list is string, of type string, then we operate on it, otherwise we continue. So that is used for that. Right, so strings. So we can use a single quote or double quote for strings. So as you can see, we have 2 strings, one in single and one in double. So it doesn't really matter. However, it's actually very useful. So, for example, you want to create a string. So you want to create a string, and this string is wrapped around double quotes. So the string itself is wrapped around double quotes. You would use the single quotes, and then the double quotes within that, and the string. So the string itself is literally the double quotes with the string. So that way you can get away with things like that without having to escape the special character. Sorry, the special string. So concatenating strings, you would just use the plus operator, and that would then add the two strings together, like we can see over there. Also, one thing that I've noticed is people try to, so if someone wants to go over a string to manipulate every character of a string, first what they would do is they would split that string and create an array or a list out of that string, and then go over it, iterate over it. You don't have to do that with strings. With strings, you can actually access a string by its index in Python. So you don't have to create an array. I mean, a string is already an array of character. So if we wanted to access the first element of the string hello, we would just access it using the bracket, square bracket notation, and provide the index 0. And then that would give us h, which is the first index of the string. We could also format strings. So actually, I corrected this format method on the train, but I don't think my Evernote synced. So this is the old way of formatting. So you would actually provide the string, and within the string you would then have placeholders. So here we have a %s. %s just says percentage, this is the placeholder, of type string, s for string. Digit would be d, and so on. However, this is obsolete. We use the dot format method now. So the dot format method is, so you would literally have the string, and then you would have, you know what, I'm just going to write it because it's just easier for you to see. Cool. Oh, okay. So now we are going to format a string. So we have the string here, I like, and then we have the curly braces here. So an open and closed curly brace. So this is the placeholder. Then we use the format function on the string. So if we provide an argument here of, let's just say, Python, you can see that whatever argument we provided in the format function will then fill up the placeholder or take the space of the placeholder in the string. So these are positional. So if I had two of these curly braces, the next argument I give to the format function is what will take place in the second placeholder. So Python cheese.
Yum.
Now, I can actually give indexes to these placeholders. So for example, I know that within my format function, my first argument is Python. Now in my placeholders, I can give the placeholders the argument number 0, 0, which just means we want to use the first argument for both those placeholders. I like Python, Python. And see, that way you don't actually have to depend on the position of the arguments within the format function to fill the placeholders. So we could have done, I like 1, 0. I like cheese, Python. Yes?
What if you had like, in your Python variable, what if you had like 2 words, like Python snake, and then you put, I like, in the formatting, in the curly braces, you put 1 or 0. Like, would that pick just Python, not the snake part, or would it pick Python snake?
So within one string, or?
Yeah, so within like, if you had Python snake instead of just Python,
Yeah.
then what would happen in I like 0?
Ah, right. So if it's wrapped around the quotation marks in one string, that's one string. So it would put both of them in there because that's one string. Yeah, so you'd have to separate the strings for you to actually have 2 strings. So that would fill up that placeholder with the string itself. Cool. So printing in Python, you would just use the print function, or print keyword actually. It's a print keyword in Python 2.7. It's a function in 3.5. So what that means is in Python 2.7, you would just have to have the print keyword in front of whatever you want to print with a space. Print, space, whatever you want to print. However, in Python 3.5, and the reason I'm actually giving you how you would do it in 3.5 is because these are, like, I would say, not major differences, but differences you should know. So in 3.5, you would have the print as a function, so you would actually open it with parentheses, and then provide the argument within the parentheses. So you can actually do that in Python 2.7, and it's just safer to do that in Python 2.7 if you want to ever move your script or your program to 3.5, then it's compatible in this regard, the printing. Right, so the first exercise. Right, so you have 4 print statements, and you are limited to the numbers 3 and 5, the math symbols of plus, minus, times, and divide, the comparison symbol of less than, and no single string longer than 10 characters. And you should have the outcome printed on, the outcome that we have on top of every print statement. So you can have like 2 minutes to try and get that.
And what's the first one? Is that number 1?
Yes. So that's number 1. The outcome should be 7. Second is the outcome should be 1 to 2, and the third is should print out Addy is awesome, and the last one should result to true.
What if we don't think you're awesome?
That's not my name anyways. Oh right, sorry. No. So we're gonna go over the results and what you've written in the Python room, hack room that we're gonna have over there, because I just don't want to waste some time just going over that. So I'll give you 30 seconds and then we'll carry on. Cool. So variables and collections. So this is actually interesting now. So right. So Python is a dynamic language. So we don't actually have to specify the type of variable we want to create. So in C#, for example, we want to create a variable, we would have to provide its data type. So for example, we want to create an integer. We would give it integer, variable name, and then assign an integer to that variable. However, in Python, you would just provide the variable name. It will work out its type on its own. So that's a dynamically typed language. C, C#, Java are statically typed languages. So you have to provide the data type. So a convention in Python is, so you can't actually have spaces in variable names, so you would have underscores. So my variable would be my underscore variable, or var. So within this variable, we want to store the outcome of 5 plus 4. So we would have, we would declare the variable and then instantiate it. And then it will hold the answer of 5 plus 4, which is 9. So if we were to print my variable now, it would contain 9. So lists. So lists store collections of data indexed by a number starting at the index 0. So I'm sure you know by now that in programming we always start at 0 and not 1. So here this applies. So we want to access a list. We would access it by index starting from 0. Alright, so I have my list here. So to create a list you would have square brackets, open and close, and that will tell Python that we want to create a list. So I have an empty list. I also have a list with elements in it. So to add elements to a list, so we have to actually separate them by commas. So as you can see here, we have 1, 5, 9, 6, 7, 8, all separated by commas in the other list. So now to manipulate the list, we have some functions, list functions, that we can use. So I have a list called myOtherList, and I want to add an element to the end of this list. I can use the append function to append 6 to the end of the list, and what that will do is just add 6 to the end of the list. So I can also remove an element from the list. So I can use the .pop function, which will remove an element from the end of the list. So if I use .pop on my other list, that will pop out the last element, which is 6. So to access and remove elements at certain positions or even ranges in a list, take example 1. So I want my number to equal to the first element of my other list. So I can just provide my other list with index 0. So that just says the number at index 0 of my other list, I want to give that to my number, or the my number variable. The second example is deleting elements in a list at a certain position. So I can use the del keyword So the del keyword in Python literally deletes. That's what it deletes. So we want to delete the first index of my other list. We can just provide the del keyword and then give the list and the index, and then that would delete the first index of the list. And by first index of the list, I mean the second, because we're starting at 0. Right, so I want to get the elements between 1 and 3 in my list. So what I can do is I would have my other list, which is our list, and then provide square brackets, and then have the starting index, colon, and the ending index, which just says I want to start at index 1, get everything in between, and then stop at index 3. So we could also use this for getting elements from the beginning to a certain point in the list. So say we have a list, we want to get everything from index 0 to index 3 of a list. We just provide the bracket notation and then have colon. So we wouldn't provide a first argument. It would just be colon, because we want to start at 0. Default is 0. So it would be colon and 3. So which just says we want everything until we get to 3. So sometimes when accessing a list, and because we can actually access lists through indexes, we can sometimes provide a number which is too high or too little, and that index just doesn't exist within that list. So I'm trying to access my other list, which hasn't got 9 elements in it, and I'm providing 9, which gives me an index error because there's no element at position 9. So say you have 2 lists and you want to add these 2 lists together, you can just use the plus operator on these 2 lists to create a list of both. So you can also use the extend function on the list to extend a list. So literally the plus operator here is doing that. It's just extending the list. Now you'll also use append on a list. So I've seen people using append on a list. So append is a function of the data type list. However, with append, you're literally adding a list inside a list. So if you were to add 2 lists together to just create a whole list of both lists, you would use the plus operator or the extend function. Don't get confused by append, because it literally adds the list inside the list at a certain index.
Okay, so that list would have its own index.
Yes, exactly.
You'd have to do the index of the index.
Yeah.
The things inside it. Right?
Exactly. Yeah. So it would just be a list within a list. Right. So this is actually very, very useful. Now, sometimes you want to check whether something is in a list. So say you have a list of names, and this is for a website where you want to have unique usernames on the website. So let's just say someone has their username. You want to check whether that username is in the existing usernames list. So all you have to do is literally provide that username, the in keyword, and your list. And then that will give us a true or false. If that username is within the list, then it will give us true. If it's not, it's false. That's a very, very, very useful function or functionality of Python. We could also get how many items are in a list by using the len function. So the len function can be used on many things. and lists are one of them. So we can actually have len and provide the argument of a list. So we can just give a list as an argument, and then that will give us how many elements are in a list. And like you can see, the result or the outcome is 4, because the size of that list is 4 elements. Right, tuples. So tuples are just like lists. So they can contain different data types, just like lists. However, they are immutable, which means that you can't change the elements in them once they're created. Right, so to create a tuple, you, instead of using square brackets, you would use parentheses, and the elements within a tuple are also separated with commas. To access an index of the tuple, you would also use bracket notation and then provide the index, just like a list. Right, so here we're trying to set index 0 of this tuple to 3. Now you can do this with a list, because a list is mutable. You can change the elements within them. However, with a tuple, you would get a type error, because you can't change the element within a tuple, because it's immutable. So you can see here, I'm trying to set the zero index of my tuple to 3, and I get a illegal type error. So you would normally use these for data that you want to be consistent. So you have this piece of data, or set of data that you want to be consistent. Instead of putting it in a list where it can be affected, it can be changed, you put it into a tuple. Right, so you could also unpack elements of a tuple into variables. So take the first example here. We're providing 4 variables separated by commas, and then equaling them to a tuple. So what we're saying here is every index of this tuple will be separated and stored into the or unpacked into the variables on the left-hand side. So you can see here that variable 1 and variable 2 are equal to 1 and 2, because we've unpacked the tuple into those variables. Right, dictionaries. Dictionaries are also very useful. So dictionaries are a collection of key value pairs. So to create a dictionary, you would give curly braces. So to create an empty dictionary, you would have an open curly brace and a closed curly brace, and that would just tell Python that this variable is of data type dictionary. So here, in my other dict, we have the first string there is the key. The value is 10. Second is also a key, and 7 is 10. So you can see the pairs are all separated by commas. So first pair, first and 10. Second is the second pair is second and 7. So if I was to access a certain value within my list, I have to provide the key. So I know the third example isn't consistent with my dictionary on the second, but say I want to access 10 in my other dict. How I would do that is by having my other dict and then accessing the value for providing the square brackets and the key. The key for 10 is first as a string. So I would provide first as a string, within those bracket notation, and then that would give me 10. It would return back the value. Like you can see here. I kind of skipped over that. But yeah, so you can see we want to access the first key value pair. So we just provide the first key, and that will give us 10, because that's the value. Right, so sometimes when accessing dictionaries, what you would have is sometimes you're providing a key for a value which just isn't there, and then that would give you an error. So for example, we're trying to access the key value pair of key third. That just doesn't exist, so then that will give us a key error. So what we can do is use the get function of the dictionary. So the next dictionary type has a get function. So we can have your dictionary dot get, and then provide the key, which is third. And what that would do is it would say if this key is there, then return back the value. However, if it's not there, proceed. Now, you could also supply a second argument to this get function, and that would be a default return. So for example, we want to access the third key or key pair, key value pair within our list. However, if it doesn't exist, we want to return something that says a string that says not there or does not exist. So we could also have get the key. The second argument would be your default fallback, which is a string of not there, does not exist. Right, so if we want to list out all the keys in the dictionary, we can use the .keys function. So say we have a dictionary, we want to find out all the keys in this dictionary. We just use the .keys function, and that will return all the keys we have within that list, which is first and second for the list we created above. If we want to do the same thing for the values, we just give the .values function, which will then give us all the values that exist within that list. Sorry, within that dictionary. So we could also use the len function on the dictionary, and what that will do is that will give back the amount or the number of keys in the dictionary. So we could also use the in keyword to check if a key exists in the dictionary. So just like my example with the list, if you want to check if something is inside this list, you can just use the in keyword. So we can see that we want to check first in my other dict, and then that would be true, because it does exist there, inside that. Right, so sets. Now, I don't personally use these. However, if you're into math, then this will be helpful for you. So to create a set, you would have the set data type, which takes in an iterable. So a list is an iterable because we can iterate over it. So we can provide a list to set. And what that would do is it would create a set of list. So what that does is it creates a list of unique values, because a set can only be of unique values. So you can actually use this, like for example, I've seen in like coding challenges, like we have a list. Could you give us back this list with unique values? And sometimes you would write like multiple for loops and just checking whether this exists in it and then removing it if it's not. Python, you would just use set. So you can use set on your list, and that will just return back a new list of unique values, and also of set data type which then you can use later on. So, for example, here we have our set, and we are adding another element to set through the add function of set. So we have our set and the add function, and then providing 6 as the argument because we want to add 6 to that set. And you can see the set has now extended or has appended 6 to the end of it. Right, so with sets, we can find the now this might not apply to you. I mean, this is for people who are interested in, math and sets. However, like I said, I don't use these personally. So, for example, you want to find the intersection of 2 sets. You would use the AND operator on 2 sets, and then that will return the intersection. So the element found in both sets. I don't want to turn this into a math lesson, but yeah, I'll keep it simple. Right. So union also is a set function. So we would just give it a pipe in between both sets. So you provide both sets and a pipe in between, and then that will give us the union of both sets. Now you can only do these on sets. You can't do these on lists or dictionaries. So it must be set data type for you to actually have this kind of behavior. So difference is a good one. So for example, you want to find the difference between 2 lists. You would first create 2 sets of those lists, and then use the minus operator on both sets, and then that will give you the difference between both of them. So finding the length and the in keyword we can also use on sets. Right, so this exercise is actually pretty long, and I think I'm gonna cut it off here and carry on inside there. That's just because if you're not really interested in Python, I don't want to bore you. However, if you are, then you're welcome to join me inside there, and I'm going to go through all of it, and we're going to cover much more and actually go through the exercises. So yeah.
Thank you, Ali.
Also, the pizza is in the Python hack room, so if you're not interested
Hang
in
on a
Python, you
second.
don't get any pizza.
That's not true. Google check.
JJ, you traitor.
Thank you, Ali.
Thank you.